Okay, so in this video, what we're going to talk about today is how can we identify and write equivalent expressions. So first thing that we need to cover today is we need to go over what distributive property is. Now, we've talked about this in the past, but today it's going to be a little more specific because in algebra or when we're making equivalent expressions, distributive property is used quite a bit. So I've given you right here the definition of it. We're multiplying a number by a sum or difference. It's the same as multiplying by each number in the sum or difference and then adding or subtracting. So I know that kind of sounds a little confusing right now, so let's go ahead and do an example. So down here, here's two examples of what it could be. So we're going to start off with the initial equation of 6 times 2 plus 4. So in this case, if we're going to use distributive property, basically what we're going to do is we're going to distribute the 6 to the 2, 6 to the 4. And that basically looks like this, 6 times 2 plus 6 times 4, because remember, we're still going to add the two add-ins on the inside. So we got to distribute the 6 to both the 2 and the 4, and then we can add the totals together. It will always get us the same answer. If we did 6 times 2, we'd get 12. 6 times 4 would be 24. And we add those two together, we'd get 36. Same thing when we distribute the 6 to each individual number here. We could do 6 times 2 is 12, 6 times 4 is 24, add them together. Even if we used order of operations, 2 plus 4 is 6, and then 6 times 6 is 36. So we're going to get the same answer each way. The only thing that we're looking at here with distributive property is just another way that we can rewrite the equation. It's a way of writing what we call an equivalent expression. So down here, here's another one, and we have subtraction in it, 8 times 5 minus 3. So same thing as if we distributed it, 8 times 5 is 40 minus 8 times 3, which is 24. So in this case, we're going to end up having 16 as our answer. We'd get the same thing here if we just did order of operations. 5 minus 3 is 2, and 2 plus 2 times 8 is 16. So distributive property is just when we can distribute that number on the outside. Remember, it's got to be with addition or subtraction. Okay, so then when we move down to commutative, or I just wanted to quickly review commutative associative identity. Remember, commutative property is when we're just changing the order. Associative property is when we're just changing the groupings. And identity is when there's no change. It's when we're either adding 0 or we're multiplying by 1. There's no change. So let's go ahead and see a few examples here. So first example, if you remember, commutative property is just when I can flip-flop the numbers. 6 times 7, or I could write it as just 7 times 6. It's just when we change the order. Associative property, well, associative property, if you remember, is just when we're changing the grouping. So right here I have C, the variable C, times the variables AB. Or I could just flip it out and take the A out and multiply it by BC. There's even one more way I could do it. I could just take the B out and multiply B times AC. It's just when we change the way they're grouped. And then if you remember, we just did distributive property. In this case, I have 3y plus 4y. So I could change that by taking the y out. And what I do is when I remove the y, I put it on the outside, and I just do 3 plus 4. It's the same as having 3y plus 4y. What I did is I just took that y out. And okay, so let's take a look at some of these right here. This is how we're going to build some equivalent expressions. So the first one here, what we're going to end up doing is we're going to change this expression so we can rewrite it in a new way. So in this case, what I'm going to use is distributive property, and I'm just going to distribute that 3 to the x and that 3 to the 2. So I'm going to do 3 times x, so I get 3x, and 3 times 2, which is 6. And don't forget, they're still subtracting. This right here is an equivalent expression to this one. It means the same thing. It's going to get you the same answer. That's another expression that gets you the same result. So let's move down to this one here. So in this case, now I got to deconstruct this one. So instead of putting things together like I did in this one, I'm going to tear things apart over here. So I try to find something that's common in both terms. In this case, remember, these are called coefficients because we have both a constant and a variable. And these two coefficients, I see that x is a common term they both have. So I'm just going to pull that term out. So the way I do that is I'll just pull x out, put it on the outside, make it a multiplication, and I'll leave 6 minus 4 inside the parentheses. So essentially, this means the same thing as 6x minus 4x, because I just pulled the term of x out of the two coefficients and put it on the outside. I could still distribute it and get the same answer here, okay? So down here, what I'm going to do is I'm going to, in this case, I want to write an equivalent expression. So I'm just going to combine like terms. No distributive property here. I'm just combining like terms to build myself an equivalent expression. So in that case, I see I have a y here. So I'm going to use a different color. That way you can tell the differences between them. So let's go ahead and use some green here. So I've got a y here, and I've got a y here. Looks like my colors are running out. And so then what I'll end up doing is here, let's not use an x. Let's go ahead and we'll just use a star. So right here I have 11x, and right here I have 7x. So I'm just going to combine terms that are similar. In this case, 7y and y, they're the same terms. This is just saying I have 7 groups of y, 7 y's. That's all it's telling me. So what I'm going to do is I'm going to add these 7 y's with this one more y, which is going to get me a total of 8 y's. Now I have 8 y's because I just combined this y over to this. So then I'm going to do the same thing here. I'm going to combine the 11x with the 7x. Remember, this just means I have, and we'll get rid of that, that just means I have 11 x's. 4, 5, 6, 7, 8, 9, 10, and 11 x's. And over here I have 7 x's. 1, 2, 3, 4, 5, 6, 7. So I'm just going to combine them. If I combine 7 and 11, I have 18 x's. So when I look at my operation here, I have add. So in that case, I needed to add these two together. And that's just combining like terms to make an equivalent expression. Okay, so that gives you an idea of how we use commutative, associative, and distributed, and how we can build some equivalent expressions. Got one more thing that I want to do with you. In this case is showing you what algebra tiles are, because you're going to see these in some of your work today, or as you get started on your Go Math assignments. So basically what happens here is in algebra tiles, these boxes represent something. In this case, a long box, whether it's left to right, vertical, or horizontal, in this case horizontal, or if we have it vertical, it means the same thing. It's just a positive variable. So I shouldn't say positive x, I'm just going to say a positive variable. Always a variable, remember, an unknown number. And so if you have a positive sign in them, it means a positive variable. If you have a negative sign, it's going to mean a negative, not x. We're going to say a variable, negative variable. So in most of your work you're going to do today, matter of fact, in all your work, you're not going to see any negatives. We're not going to work in negatives today because I want you to just understand what algebra tiles are. So the long box means a positive variable if it has a positive in it. The long box with a negative sign in it means a negative variable. So let's drop down here. If we look down here, this is going to mean when we have a small box with a positive in it, it means it's a positive constant. So if I have one positive constant, it's just 1. That's all it means, it's just 1. So down here I have 5 positive boxes, or what I'd say positive constants. So since I have 5 positive constants, it actually equals 5. That's all it equals. So remember, the long box equals a variable, the small box equals a constant. So if we did this over here, we had 1, 2, 3. I just wanted to show you if you have 3 boxes with nothing in it, remember it always means positive. And so it just means 3 positives or 3 positive constants. Okay? If it's negative, it must show the negative symbol in there. So in this case, we just say this is a -2. We could write it as a -2. We could write it as a -2 constants. So just remember the small boxes like that are always constants. So let's do a few examples. Let's say that I have something that looks like this. It gives you 1, 2, 3, 4 small boxes, and then I have 2 larger boxes. So if I'm going to write something like this, I want to keep the 2 terms separate. So in this case, the 2 terms right here, these all mean constants, so that really means 4. And so then when I look at this, I see that I can't just combine these two because they're not combined together. So it's telling me that I have to put together these two. I'm going to add them together. I'm smushing them together, and it's going to be 2x because I have two variables. I picked x because x is common. I could pick any variable. I could say 2y, I could say 2c, I can say whatever variable I want. Now the common variable we use in algebra is x, so that's why I went with x. So this would be 4 plus 2x. Let's say we added to another long one and another long one. Let's say we added two more small ones. So in this case, now we're going to have 1, 2, 3, 4, 5, 6 total constants, and then we're going to add that to 4 variables. And remember, this 4x just means it's 4 x's. That's truly what it means. I'm just combining them together so I can write them as a 4x. Okay, so in this case, this is what algebra tiles look like. And so sometimes it can get a little bit crazy. Sometimes with algebra tiles, what they'll do is they'll give you a crazy problem, like they'll say, well, here's a long one and a long one, and then we have a small one, and then we have a long one, and then we have two small ones, and then let's say we have a long one, and a long one. So in this case, what I would end up doing when I write this, you could write it multiple ways. I mean, in this case, I could write, let's see, we have 1, 2, 3, well, let's start with the constants. 1, 2, 3 constants. And then I have 1, 2, 3, 4, 5, 6 variables. So I just add 6 variables to that. So that's the way I could write this, by combining all of the algebra tiles. Or I could even write it another way. If I see in here, I see a variable, not a variable, but a constant I could pull out that they both have. They both have the number 3 in there. So I'm going to pull out the 3, and I'm going to rewrite this as an equivalent expression. Pull 3 out. This will become a 1, because I know 3 times 1 is 3. And then I'm going to add that to 2x. So this is an equivalent expression, because right here, we just pulled the 3 out. We used the distributive property on that one. So just another way of writing this set of algebra tiles. Okay, so today was all about equivalent expressions. We covered distributive property, commutative associative property, and we even covered some algebra tiles in there. Okay, thanks.